Okay, Jared, we're going to look at the form tolerances today. Wonderful world of form. And in here we're looking at mainly the straightness, flatness, circularity, cylindricity, and the important things to remember is that we're just looking, when we're talking about form, it's the shape by itself, if you want to think of it that way. It's not using a datum. It's referencing itself. A perfect form, example, or sample, however you want to think of it that way, but it's not related to a datum. Okay, so they're applied to a single feature or an element. Okay, so if it's a shaft, then cylinder, we can look at just one element on there and its circularity, one circle, or cylindricity over the whole length of it. Okay, just like straightness can be a single line on a flat surface, or cover the whole surface, which would be flatness. Okay, so single line straightness on a shaft or a flat surface is just a single line. So if it's on a shaft, we're running the length on the outside of the shaft, parallel to the axis, one single line. That's how we'll measure it that way. And if it's a straightness on a rectangular shape, then it's a single line. And the single line is parallel to the how we had placed the geometric control frame, where we're pointing. Okay, but the main point is that it's not related to a datum. Now, we will use form tolerances on a datum from time to time, but it's not related to a datum. Okay, so it doesn't depend on a datum, but a datum can use a surface that has a control on it. Okay, so if you think about it, the straightness and the flatness, single line, and then a whole bunch of single line, a whole bunch of elements, geometric elements. Circularity, one little circle around the shaft, or cylindricity, the entire. It's like taking flatness and making a tube out of it, if you will. Okay, so how we apply it and the specifications for it, the symbol are provided, and the little note that they have on page 178, just reiterating what I said, form tolerances can be applied to individual features, feature elements, or features of size, including datum features. Okay. Applying a form tolerance to a datum feature does not relate the tolerance to a datum. This application is discussed later in this chapter, and what that's referring to is where we're a company that's making gaskets or rubber seals or whatever, plastic, flexible polypropylene parts or something, bendy. So we may actually have to use it in association with a datum device, and actually making the fixture that's going to hold the gasket or flexible part semi-rigid, okay, so that we can do something to it or check it, possibly, kind of a device that would simulate what it's going to be mounted on in a kind of an average extreme situation, so we can make sure that over a range of measurements it's going to work. Okay. Now, some idiosyncrasies about straightness. So the straightness tolerance, we have a feature control frame, and on page 179 we see how we can apply it. We can apply it with a leader pointing to the edge, or we can apply it to the actual diameter dimension. That's speaking of applying it to a shaft here. Okay, so we consider it regardless of feature size. Okay, and so therefore perfect form is required when we make our shaft at MMC. And then because it's RFS, then the geometric tolerance is maximum out of straightness is held throughout the range of parts. As soon as we move an amount, we make it smaller than the geometric control. So the difference between produced sizes here, 6.1 to 6.2 on our little chart, is 0.1. So it's already gotten smaller than what our geometric control is forming. It's moved further away from it. So therefore, the geometric control applies. Okay, if it had been a smaller amount, a closer amount, closer to 6.2, then that would be the geometric control. Okay? So it's until you reach that amount. Okay. All right. Surface straightness applied using the independency symbol. As I think I've told you all before, this is a new control that I had not studied. Okay, so it's something they've come up with because apparently, you can want to control straightness, and it's kind of okay if it's a little bit bigger. Okay, it's kind of unusual, but so you don't have to have a perfectly straight. It's okay if it's still out of straightness, even though it's a little larger. You're looking at RFS. So in this case, since it's independency, then your maximum out of straightness then is held the same, no matter if it's produced at MMC. So that creates this condition called virtual condition, and it's where we have taken the out of straightness possible, the maximum, and then the maximum size, in this case, MMC, you add that together. So your surface is out of straight, 0.3, and then the shaft itself is 6.1. So that combination, called a virtual condition, creates this envelope that it's going to fit within as 6.4. Okay, well, our tolerance, allows us to go up to 6.1, but in reality, the part is allowed to be curved or out of straightness that amount, plus the size. Okay, so really you end up with a virtually larger part that you have to guarantee that's, if you're going to use this kind of specification and allow it to be out of straight, then you have to guarantee that what it's mating up with and what's being used with, if that's going to be acceptable, it's going to work over the range of tolerance. Okay. Then the other is axis straightness. And this is where we tie a cylinder diameter tolerance zone that's actually a cylinder running the whole length of the center of the axis, has its own specification of 0.05. And since it's RFS, and I believe they're still considering this as independence because we're holding the independency, because we're holding it at 0.05 according to the chart here, which we do. So when we do an axis control, RFS is assumed and perfect form is not required at MMC. So it's like independency, but independency is usually for the surface, the outside. Okay, so this has always been before they created this independency symbol. So they're kind of like, you've got a virtual condition here. You know, if you think about it, your acceptance boundary, okay, 6.25. Well, it's actually 6.2 is our possible produced size. So acceptance boundaries like virtual condition. It's the combination effect of the size and the tolerance, geometric tolerance taken together. Okay? All right, let's see. We're looking at, it's interesting that they put it under independence.